Greetings and welcome to the video lesson in Pre-Calc, sections 6.1 and 6.2. So this will be several mini video lessons. To begin with, these sections we'll be talking about law of sines and law of cosines. And at this point you should have some familiarity with these two through your study of Algebra 2. Now we're going to enhance that a little bit and we'll see how as we go through these notes. However, I would like to start with a recollection of what a right triangle is, or right triangle trig. When we're dealing with right triangle trig, you might have heard of the trick to memorization of SOHCAHTOA, but in this case we're looking at sine theta is being the opposite over the hypotenuse. Remember, the hypotenuse is the long side of the triangle, the side opposite the 90-degree angle. The cosine theta is given by the adjacent over the hypotenuse, adjacent being the side next to the angle we're looking at, the angle theta, but not being the hypotenuse, and tangent theta, which equals opposite over adjacent. Now, I have a triangle drawn here for you to look at, and the reason I have this triangle drawn is normally we see them when we're dealing with right triangles given as angle A, angle B, and angle C, where C is the opposite side, or C is the angle of the right triangle, and its opposite side is C, or the hypotenuse. And then we would make little a opposite A and little b. In this case, I just want to use A, B, and C, where the angle A, then the side next to it would be little b, and the side opposite little a, or non-capital, and then looking at C on this side. Now if this is true, then sine of A equals its opposite, which in this case is A, lowercase a, and then the hypotenuse in this case is B. Now if I want to solve for A, or solve for that hypotenuse, I would simply multiply by B and then divide by sine A. But in this case, I'm going to really look at A as the height of the right triangle. So if I want to solve for that height, the height of the triangle is really B times sine A equals A. So this is the height. And sometimes we'll designate that with an H. Now I will come back to this when we look at some ambiguous cases for a side-side angle as given as information. So what I'm going to do is I'm going to jump around a little bit right now, and I'm going to show you that in Algebra 2, Chapter 14 of our book, we studied the law of sines and the law of cosines. And you'll remember that the law of sines had two cases. Case one, where we had the sides on top, so the ratio of the side over the angle. And then times where we chose to have the angle over the side. Now these are both useful depending on what I was looking for. If I was looking for a side where I had a side that was unknown, I would choose to have the sides on top, so I wouldn't have to do an extra step. Likewise, if I was looking for a angle, I would use the angles on top. And we'll talk about that further at a later point. Law of cosines, they were the following. We probably studied it pretty much left to the left side here, but there was mention where we could solve for the cosine of A, the cosine of B, and the cosine of C. Now take note that if I'm looking for the side A, I must be given the angle A. So they're kind of like bookmarks, they're the end points, the beginning and the end. And then you'll notice that everything else inside consists of B's and C's. And one way we remember this is that there are two A's and there are two B's, and there are two C variables in each problem. Likewise, when we had solved for side B, we have the angle B, and the side C, the angle C. So that's just a reminder, that is where we're going. Those that are in my class, you have these notes, and we're going to consider those in the cases of law of sine and law of cosine. Now you'll notice I wrote them together here, and I gave case scenarios for those. So this would really be an angle, angle, side, and then this would be an angle, side, angle, meaning the side falls in between the two given angles, and that's when we're going to use law of sines. Likewise, when we have a side and then an angle, which means these two match up. So if I'm given the measure of angle A, I'll also have the side A. Now, for the law of cosines, we'll see that we have a side, angle, side. So the angle falls in between the two given sides. And then a case where we're given all the sides. And so, again, this is sort of a brief overview of law of sines and cosines, and we'll get back at that. Now I'm going to go back to where I was talking about right triangle trig, and we had given you, in this case, b sine a equals h, so a height. And we're going to use that for these oblique triangles, which we're going to point out right now. Now, what is an oblique triangle? An oblique triangle is a triangle that does not have a right angle. So it does not have a right angle. If it did, we would just jump back to right triangle trig. Now, an ambiguous case, or the ambiguous cases, take place with the side-side angle condition. So this is the side-side angle. You remember that is when we're going to use the law of sines. And we'll get used to that, and we'll practice that quite a bit, so don't panic at this time. Now, when we have this, we have two possible triangles that could be formed. We could have one triangle that's formed, or even no triangle formed. And so we're going to consider two cases. One where the given is obtuse, and one where when it's given as an acute angle. So in this case, the angle given is an obtuse. Now what happens? Well, the opposite side of the angle given is less than or equal to the other given side. Now that means no triangle is possible. A picture is definitely helpful here. So let's say I am given angle A, and it starts here, and it goes across. We'll just make it go straight across the bottom. Now, if angle A is obtuse, and we'll call this side B, what this is telling us is that if my A, which is supposed to be opposite side of this, is shorter than the B, it's not going to reach my bottom side here, which would be in this case C. So my A is not going to reach. And even if it were the same size as B, the best we can do is match it up, and I would only have a two-edged object. Well, some people are saying, well, what if you go this way? Well, then I don't have any longer this obtuse angle here. And that is what I'm looking for. So the case would be basically here, where if I've got angle A, the side A is less than or equal to the side B, which is adjacent to my A. So you can see that case. So no triangle. Now the next case talks about when the opposite side is greater than the other given side. So once again, I'll draw an angle or a side C here on the base. My angle A is given as obtuse, meaning larger than 90. And then my side A, which is opposite, is actually longer than this B. So it would allow me, if it was just a little bit longer, to reach here. If it was a lot longer, it could reach all the way out to here. But we're going to get some kind of triangle formed with this obtuse angle. Okay, so in this case, we're just going to get one triangle. Now this brings us to the ambiguous cases where the given angle is acute. Now that means less than 90. So when we're dealing with these triangles, we have several possibilities. The opposite side is less than h. So remember, h is the height of the triangle. So what that is referring to is the case where I have my angle A, it is an acute angle, my side B, and then if I drop that straight down, that would be my h. And what this is saying is, hey, what if A is shorter than that? So if A is shorter, it might reach here, here, and you can swing it out here. But any way we look at it, A will not touch the side C. Therefore, no triangle can be formed. If we look at case 2, and case 2 is where the opposite side is greater than H and larger than the other given side, we're going to have one triangle. So what that means is we have our bottom line, we'll call C. Our angle A is going to again be acute angle, and there is B. Now what is the possibility if A is larger than B? If A is greater than B? Well, if it's greater than the H, it can't possibly come back this direction because it is larger than B, and we go through the base side of C. So that wouldn't work. So the only choice that we have is to have it shoot off in this direction as a dotted line. So then our C would have had to been given as longer. So if A is larger than B, we're going to get some triangle that looks like this. Now the final case, and we're running out of time here, is when the opposite side is greater than B, but less than, or greater than H, but less than the other given side. Now what this pertains to, we'll have to show two cases. The first case, again, we'll have side C, and we'll have B expound from that vertex, and there is A, and there is my H. And what this is saying is that the angle is larger than H, so it could come in here, a little longer than H, creating a acute angle there, or it could expand and go onto this side. And what you'll see is we have two angles created then. So we have the one triangle that it's longer than H, and it goes inward. So the angle created is here, the triangle. And then we have that same condition where we would have this angle and be longer than H, but now it goes out here. So to the right, and it makes that type of a triangle in view. So what that tells us then is we have two possible triangles. Simply if we swung this arc out, so if I started here, look right there, if I started there and actually swung this out, it would make a little bit of an arc and then retouch back here. You can see that we'll get two triangles. So we'll need to consider that when we're given a side, and angle and solving for triangles of that nature, which again will cause us to use the law of sines. Thank you, and I look forward to talking to you in video number 2.